Day 227 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 207, and today we have question number 226. So dang, yeah, I probably should have did this question yesterday on day 226, but hey, I didn't know. Maybe next time we could do it like that, but we're going to get through this problem anyway. So today we have question number 226, invert binary tree. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. So let's get into it and see what the question says. Question says, given the root of a binary tree, invert the tree and return its root. So it's pretty self-explanatory, but let's look at these examples just in case, because it may get a little tricky. But what we're doing is, so let's look at example one. Example one, we have the input root equals a binary tree 4271369. The output is a binary tree 472963 and 1. Now, if we look at these pictures up here, we can see all they did was first they inverted these two, right? So first the root stays the same. So 4 stays the same on both, but the subtrees, right? We come right here, and it's a 2 on the left subtree and a 7 on the right subtree. But after we invert it, the left subtree becomes a 7 and the right subtree becomes a 2. So we just inverted these two values right here. Now, we're not done, because as we come down here to the child nodes as well, the rest of the leaf nodes, we also have to invert these. So this 9 comes on the input. This 9 is on the right side of the 7, and the 6 is on the left side of the 7. So we also have to swap those, and now the 9 is on the left side of the 7 and the 6 is on the right side of the 7. And we have to do the same thing with the 2. And the input, the 1 is on the left side of the 2 and the 3 is on the right side of the 2. But on the output, the 3 is on the left side of the 2 and the 1 is on the right side of the 2. So we have to invert these nodes and these nodes as well. Only thing that stays the same is the top root head node, right? So that's how it works. Let's look at example 2 when it's a little less nodes to work with, but it's pretty much, it is the same thing. It's just a little easier. So in the example 2, we have the input root equals a binary tree 2, 1, and 3. The output is 2, 3, and 1. Same thing. We keep the root head nodes the same. Boom. Then we swap the 1 and the 3, right? So at first the 1 is on the left side and the 3 is on the right side, but after we swap it, the 3 will be on the left side and the 1 will be on the left side. Then let's look at example 3, where it's a blank array. So the input is root equals a blank array, output is a blank array as well, right? So if it doesn't exist, then we could just return a blank array. Now that we understand the question, y'all, let's get into the solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, go ahead and like, comment, and subscribe. So let's get into it. And today, y'all, I got 2 solutions for y'all. I got the first solution. It's going to be pretty simple. It's going to be most likely some things that you guys have seen before. And then for the second solution, I'm going to show y'all something new, or at least it's new for me, something I've never seen before. So I figured I'd show y'all as well, because it has some few things that you might learn something, you know. I know it taught me something, so I want to teach y'all something. So first thing we need to do is we need to have a base case if the current node or the root is nil, right? So in order to do that, we just have to say that, and that's going to handle like example 3, right? So we're going to create a guard statement in case we have an example like example 3. And in order to do that, we're going to say guard let root equal root, else open the brackets, we are going to return nil. Boom, just like that. Then we're going to come underneath that and we are going to recursively invert the left subtree and store the left subtree in the left constant that we're going to create. So we're going to create a constant called we're going to call a constant called left. So we're going to say let left equal, then we're going to recursively call this right here invert tree, right? So invert tree. Then we are going to open up the parentheses, and for our parameter, we're going to pass in root.left. Then we're going to do the same thing for right, so it's going to recursively invert the right subtree, and we're going to store that in a constant called right. So we're going to say that, do that by saying let right equal invert tree. Make sure my spelling's right. Okay. Then we're going to pass in the parameter root.right, just like that. And now we need to swap the left and the right subtrees of the current node. And in order to do that, we're going to say root.left equals right. Then we need to do the same thing for the right side. So, say root.right equals left. Boom. And it's that simple. Then we just have to return the current node, and now the subtrees will be inverted. So we're just going to say return root. Just like so. So let's run it. See how it runs. Boom. So let's submit it. Make sure it stays accepted after we submit it. See what that time looking like. Ooh, 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. Faster than a Bugatti riding past Andrew Tate and the rest of the brokers, y'all. Now, that's the first solution. Let's get into the second solution, where it's actually, we might have something new, right? It was something I've never seen before. I don't know if y'all seen it before, but let's get into it. First thing, we're going to do the same thing. We're going to check to see if the root node is nil, and if it is nil, we're just going to return an empty tree, right? So in order to do that, we're going to say guard let root else, open up the brackets, return nil, just like that. Boom. Then what we need to do is we need to initialize a stack with the root node, and this will be used to traverse the tree, right? So in order to do that, we are going to say var declare a variable called nodes, and we're going to set that equal to an array of root. Boom, just like that. Then we're going to come down here, and we are going to continue to process the nodes while the stack is not empty by saying while let node equal nodes dot pop last. Boom. Hold on. Pop last parentheses. Just like that. Now we're going to swap the left and the right child nodes of the current node. And this is the new thing I'm going to talk about. We're just going to call swap. So we're going to say swap. Then we're going to say and, put the and sign, put a node dot left. So it's going to be and side node dot left. Then we're going to do the same thing. It's going to be the and sign node dot right. Boom. And that's what I'm talking about. This swap with this and sign. That's something I've never seen before. So I figured I'll show it to y'all. And so what it is, when you see the and sign before a variable, right, that means you are passing the memory address of the variable rather than its value, right? And this is going to allow the function to directly modify the original variable in place rather than working on a copy. So that's what this and sign does. And this is that swap function. This is that new function, that new way, something I never seen before. I never seen somebody call swap before. So I figured I'd include this in the solution as well. Now what we're going to do is we're going to check to see if the child node exists, and we're going to add it to the stack for further processing, right? Remember, we created this stack up here. So in order to do that, we're going to say node.left.map. Open up the brackets. We're going to say nodes.append, open up the parentheses, $0. Then we got to do the same thing for the right side. And we're going to say node.right.map, open up the brackets, nodes.append, open up the parentheses, $0, just like so. And then after that, we're just going to come outside of the while loop, and we're going to say return root. Boom. So let's run it. See how it runs. Let's see, and it's accepted. So let's submit it. See what this time looking like. Drum roll, drum roll. Ooh, look at that. 0 milliseconds beats 100% of users with Swift, y'all. Faster than the Bugatti riding past Andrew Tate and the rest of the brokies, y'all. You know how we like to do. So I hope y'all learned something today. Get one more look at this code. If you need to rewind, get one more look at the last code, y'all. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.